Okay, so let's start with our AtliQ Hotels data analysis project, where we will start with data import and exploration. So, first code that we write is import pandas as PD. So, pandas is a Python library designed for working with structured or tabular data. Essentially, data organized into rows and columns similar to what we see in Excel and SQL tables. Okay. I'm importing it as PD. This is simply the standard shorthand used for pandas. So instead of writing pandas every time, I can use PD. Okay. Now that panda is available, we can start bringing our CSV data into Python. As you can see, we have 5 CSV files: dim date, dim hotels, dim rooms, fact aggregated bookings, and fact bookings. So the first data set which I want to explore is the factbooking.csv. So I will just write the code for that. First, I will store it in a data frame, that's df. Okay. So data frame is essentially pandas table-like structure where our data is organized into rows and columns. So why this matters? So you see, read.csv is storing the data set, like for the whole table, into this data frame of df dash bookings. Okay, remember that. So once we have the CSV file and it's stored in the data frame, we will do df.bookings.head parenthesis. The both bracket open and bracket close is like parenthesis. We call it parenthesis. Okay. So it gives us a default, uh, like it displays the first 5 rows of the data frame, which is like a default setting, you can say. This kind of gives me a quick preview without printing more than like a lakh records on screen, right? So from this preview, I understand the structure of dataset: booking ID, property ID, dates, number of guests, room category, booking platform, then there's ratings, booking status, revenue generated, and revenue realized. So as you can see, the negative number, there's like a negative number for no guest, right? Which kind of doesn't make any business sense. But since we are exploring, we won't go in detail right now. But yeah, we'll go in the data cleaning part. We will have our part of cleaning it. But yeah, right now, I don't think so it's needed. Then we write the code dfbooking.shape, which gives us 1,34,590 rows and 12 columns. Now, I understand that the column represents like what the column represents, but I still don't know how large this data set actually is. That's why I'm using shape, right? So this is like because it's like a fact booking table. So each row represents an individual booking record. If multiple hotels are processing bookings every day across several months and booking platforms, accumulating more than a lakh transaction is completely reasonable. Okay. And as you can see, the 12th column represents different attributes captured for those booking records. Mm, so shape kind of gives me a very quick understanding of volume and the width of the dataset before I go deeper. Now, let's move on to the room category. We use room category. Okay. So we get the array RT1, RT2, RT3, RT4. Okay. So why we use like instead of looking through like 1,34,590 rows, I mutually try to find every possible room category, right? So unique, that's why you use the unique function, because we want to find the unique categories of the rooms. Okay. So unique basically returns each distinct value only once. And we can see that the booking table contains 4 room category codes, that is RT1, RT2, RT3, and RT4. Okay. This is important because there are these are IDs rather than descriptive room names. So remember our early discussions about the dimension tables that we had. The booking fact table doesn't need to repeatedly store names such as standard, elite, premium, or presidential. It can store the room category code, which can later be connected with the room dimension table. So unique helps me understand a distinct category actually exists in the field. This kind of connects the Python code directly to the earlier theory. Now let's explore the booking platform. We again use the unique function. So here's my question. Through which channels are customers making the hotel booking, right? So again, unique is useful because I don't need every booking. I only want the distinct platform names. So the result shows channels such as Make Your Trip, Lock Trip, Tripster, Journey, Direct Offline, and so on. So now I know which booking channels exist. But this creates another question. How many bookings are actually coming from each platform? And unique parenthesis cannot answer that, right? So that's why for that I need value counts. So again, uh, why do we use value counts here? First, we have used unique, where we get all the unique platforms. Now we have used value counts to count how many times each unique value appears in a column. So whereas unique answered what booking platform exists, value count answers how many booking came through each platform. Okay, remember that. Unique answers what booking platform exists, while value counts answers how many booking came through each platform. So now we get a much more useful picture. As you can see, the others categories has the highest booking volume, followed by Make Your Trip, Lock Trip, Direct Online, Tripster, Journey, and Direct Offline. So at this point, though I wouldn't conclude that the platform with the highest booking count is necessarily the best performing platform. You may ask why, because booking volume is only one metric. Later, we could also consider revenue cancellation, realized revenue, or other performance measure. For now, this is purely an exploration of booking volume by channel. That distinction is analytically very important. Okay. So so you may think, why do we convert this value counts into a bar chart? So as you can see, visualization actually helps us recognize the patterns quickly, right? So tables gives us precision, but visualization help us recognize patterns quickly. And that's why we use the plot kind is equal to bar to create visualization, while yeah, uh, basically plot parenthesis creates a visualization, while kind is equal to bar tells pandas that I specifically want a bar chart. So I hope you understand the code. Moving on, we use describe function on the same data frame. Since I've explored some categorical columns, I wanted a quick statistical overview of the numerical data. And so as you can see here, uh, the minimum number of guests, as you can see, is minus 17. So that's kind of impossible in real world. So describe parenthesis has immediately helped us identify a potentially data quality problem. Then we move on. Then you see the revenue thing. So the maximum revenue generated, okay? The maximum revenue generated, as you can see, it's dramatically higher than the typical value shown by quartiles. But that doesn't automatically mean it's wrong, but it gives us a reason to investigate it, right? And that's exactly what exploratory analysis is supposed to do. Find areas that deserve deeper investigation. And yeah. And then we load the remaining CSV files. Then we do the shape. So we do the DF hotel shape and we get 25 columns, sorry, 25 rows and 4 columns. And here they are. We do the head, we get the rows and columns. Then we again do the category value counts. We get from here we get to know that luxury has 16 and business has 9. Uh, what we say? Uh, Rooms. So yeah. So basically, as you can see from the value counts, category column basically tells us whether a property belongs to luxury or business segment. So you can say how many properties belong to each category. So the result shows 16 luxury hotels and 9 business hotels. This kind of gives us a context about company's portfolio and also creates another dimension we can use later, when comparing company's performance. Again, we use so now as you can see, I've taken the city column, which is there, and we use df.hotels or city.value counts or plot kind is equal to bar. So I've used here value counts to calculate how many properties exist in each city and then visualize those counts using a bar chart. Now we can see Mumbai has 8 properties, Hyderabad and Bangalore has 6 each, and Delhi has 5. So again, this tells us a distribution, not performance. Mumbai having more property does not automatically mean Mumbai generates more revenue per hotel or perform better. Moving on to aggregated analysis. Finally, I'm previewing the aggregated booking data set. Unlike fact booking, which contains individual booking transaction, this table provides summarized booking information at different levels. So as you can see, we have property ID, check-in date, room category, successful booking, and capacity. So the last 2 columns are particularly very important, like the successful booking. It tells us how many rooms were successfully booked, while capacity represents the available room capacity for that combination. This means the dataset can eventually help us answer a very important hospitality question. How effectively are we utilizing our available room capacity? And this kind of will later lead us towards occupancy analysis. So then there are exercises which we have done. As you can see, the first one is find out unique property IDs in the aggregated booking data set. We do the same thing, aggregated bookings, property ID dot unique. Then it's to find out total booking per property ID. Again, we use the group by functions. So why the group by functions, you may ask? Like, why do we use group by functions? I want you to think. Why do we even use group by? Just think for a second, right? Just think for some time. Because the more you think about it, the more you will remember, right? Why do we use group by function? Super, super important to remember it. Mhm. Okay. So anyway, I'll tell you. So, uh, so basically, group by it groups all records belonging to the same hotel or property. And successful booking basically says that, those groups who are interested in the successful booking column, and then there's sum. Okay. And then we have also done the reset index so that we get the columns properly, property ID and successful booking. Moving on, we have third exercise, which is find out the days on which bookings are greater than capacity. So as you can see, we have just used the function, we have used the list, and inside the list, we have used successful bookings is greater than capacity. And that's how we get the bookings, uh, like which books are greater than the capacity. So yeah, as you can see it very well. Moving on to exercise 4, find out the properties that have highest capacity. So we use the code df aggregate bookings capacity dot max. So I think we are clear here with the data exploration part. In the second video, we will have data cleaning. I hope you learned something from today. That was the main point of making this video. Thank you so much for